Hello, this is Dave Hammer, an amateur blacksmith who has a little experience to share with you today. This video is the third in a series of videos I'm making to show how a blacksmith can fabricate a propane forge. The topic today is learning how to put a high-performance lining in the Super C. These videos are for my friends and fellow blacksmiths. Please read these cautions and take them seriously. The materials that we're using today are extremely dangerous, and you must follow safety procedures to protect your health. MSDSs can be found online by Googling for the product. This is a Super C Forge, which was the object of an earlier video, how to build it. Today we're going to learn how to put in the thermal blanket, the floor, and the refractory coating. The first task will be to put a 1-inch thermal blanket around the entire interior of the forge. You can buy the thermal blanket either by the box or by the foot on eBay. Buy 8-pound blanket. First we cut two pieces that are as long as the length of the forge. This stuff comes in 24-inch widths, and this is long enough. This width is long enough to take care of the interior of this forge. I need to cut two pieces. I use a metal yardstick and a linoleum knife to cut this. You can also cut it with a large scissors or tin snips if you need some unusual shapes. Be careful not to cut your fingers. You should wear a mask and gloves when you're handling this stuff. It's actually a ceramic fiber, and if you have dust flying around or fibers flying around, you really don't want to get those in your lungs. Read the MSDS, Material Safety Data Sheets. If you Google like INSWOOL or INSWOOL space MSDS, you'll find somebody's version of it. I'm checking the length here. It's a little longer than I need, so I fit it in there and mark it with a Sharpie. Bring it back out and cut it. When you're putting this in, you need to stuff it in tight. You don't want it loose. In a minute we're going to be actually gluing that in so it stays in, and then later putting a second layer. Use the knife again. I use sodium silicate to adhere the thermal blanket to the inside of the forge and each layer to the other layer. This is a product that you can buy at ceramic supply places. Put it on fairly liberally. We use a full strength. Put some on the blanket. You'll notice here that I got the thermal blanket dirty. Not a good thing, although it's certainly not a big problem. The piece of sheet metal I have on my table, I pulled out of a rack, and it was dusty, and I didn't realize it. I should have cleaned it first. Need to roll this up to get it in. Again, this is 1-inch KO wool. You can buy 2-inch. It's just harder to work with. Put it in there and tuck it under the under the shelf and into the top of the horizontal opening. Be sure you have good forge body contact. I fuss with this a lot when I put it in. I want to make sure that it goes in flat. There'll be another video on about how I made this floor. I'll be putting this in and taking it out several times. I want that floor to be about 1/4 of an inch or so higher than the shelf. And that's so when we have fire in the burn chamber, we don't have fire licking at steel. The horizontal opening is most of the time will be covered with soft fire brick. And that soft fire brick gets pushed in and part of it over the floor. The floor was a little low with just the 1 inch of insulation, so I took a piece and I split it in half and put it in there. We put a second piece of a second row of insulation from the back side of the floor all the way around to the horizontal opening. I just approximate that length and cut it. I want it a little bit long because when I put it in, I want it to hang down into that opening, and you'll see why a little bit later. We also used the sodium silicate to glue this piece of thermal blanket to the other piece. Put this back in. I push that down a lot because I want that compressed. I don't want that to be settling after the lining is finished. Here I'm just going to put it in and check and see if it's an appropriate length for the way I want to install it. Who's that guy with the bald spot? The length is fine, so I'm going to roll it up and pull it out. We're going to put sodium silicate on the lining inside and then a little bit on here. You can buy sodium silicate. You could buy a quart, or you could buy a gallon, or you could buy more if you thought you needed to, like for a group or something. A gallon will go a long ways. One of the bottles I have is a gallon. I bought probably, I don't know, at least 15 years ago, maybe longer. And I've made numerous forges, and I still have part of the original gallon. Put a little on this. We're going to be gluing this to the other strip in there. I put this on fairly liberally. It'll soak in some. Put your tools away, Dave. The floor will stay in after this. I want it to be level, so I'm going to check it. The shelf is presumably level, so I just check it against that. Roll up our second piece. push it hard down against the floor. Just don't tilt the floor doing that. And then push it and just keep working it until you're confident that the pieces of thermal blanket are stuck together. We just let this sodium silicate air dry. You want it to be completely dry before you go on to the next step. How long it takes is determined by how much you put on, how much it's soaked in. You know, it takes at least a few hours for that to be dry. Most of these major steps you should wait a day before you go on to the next one. Putting this kind of a lining in a forge is not a one-day project. It takes a while to do it, and some of the steps you need to leave the coating dry. You need to get it dry. Every step needs to be bone dry before the next step is taken. This is the reason I wanted that to hang down a little bit. I want a nice clean cut across the top of that opening. It may not appear it so much, but I'm cutting on the return stroke when I'm moving that back and forth. I don't want to push that away. And I'm holding it on the inside with a gloved hand. But I'm cutting on the return stroke so I don't push it away. You want a nice clean cut. The next step is to cut out the hole for the burner. Put a glove on and stick it in there and hold that blanket up against the forge body and use that long knife in there, holding the blade kind of cramped against the edge of that circle on the forge. This needs to be a clean cut. When you look down in there, you shouldn't see any fraying. We're going to take the forge apart. You remember that this is kind of, I called it a convertible of some kind. So the top comes off of the bottom of the forge. It'll make it easier to line, to put the coatings on. You don't want to try to do this before you have that those two layers in on the floor end. Just cut that over to the forge body. Use something to provide support for that top when you take those bolts out. Loosen these bolts. Right now those are just bolt holes on that bracket that's welded to the top. You'll see later that those are, I've cut those to be slots. You'll see the reason why. I use either a piece of metal or a wooden dowel or something just to level all this out. I probably should be wearing gloves here and a mask, but you need to read the MSDS and see, you know, how stringent you want to be with the safety equipment. These are very fine fibers. I would recommend you wearing gloves and a mask. This is a little bit of a lapse for me on the safety. Push those sides in. We're going to be putting almost a quarter of an inch of coverings on there, and I want the edge to be even with the edge of the forge. This is a colloidal silica. You buy it from an industrial supplier. What we're putting on now will act as a rigidizer, and colloidal silica is mixed 50% colloidal silica and 50% water for doing this. You want this to soak in a little ways. You don't want it to soak all the way through, but you want it to soak in probably at least a quarter or a little more than that inch. That will act as a rigidizer. This has to be, at least I want you to cool this, I'm sorry, dry this in a heat chamber. Excuse me. And it can be dried at a temperature up to several hundred degrees. Now, to do that, I'd need a large kiln, which I don't have. I thought about making one, or you can go buy one for several $1,000s, or you can use a cardboard box as a heat chamber. This is, see the vent holes there? With this cardboard box for a heat source, I use a 1500 watt ceramic heater. Now just make sure that when you stick that up against the cardboard box, you're not, the front of it or nowhere near the burner is touching. This has got the fan and the grill in the center. This model I bought at Walmart for about 18 bucks. Works wonderfully. It may not seem that safe, but the flash point of cardboard's over 700 degrees Fahrenheit, and the hottest I got one of those boxes with it is 180 degrees, and that was without anything in it. When I was testing it, if you're a little skittish about it, you can make a metal box or a metal frame for the heater to keep it more away. And that's done, and you'll be checking that off and on. Just remember that all this has to be bone dry. You do not want any moisture in there when you put on subsequent coatings. If there is, it'll generate steam later, and it'll blow out the whatever, either wrinkle or bubble out or crack, whatever subsequent coating you put on. We're gonna, the next major step is to put a slurry on here of zirconium silicate. Before we do that, we prepare the surface with a 50% solution of water and colloidal silica. It softens the surface, and then we mix a slurry using 100% strength of colloidal silica and milled zircon or zirconium silicate. This is by far the most dangerous compound we're working with here. This stuff is milled down to the nanometers, and it's extremely dangerous. You don't want any air moving in your shop. You don't want to raise any dust. You don't want to be, you don't want to clean up with forced air. You want to be very careful and clean up carefully with this, and be sure you wear gloves and a mask and eye protection. Read the MSDS. We make a slurry that is about as thick as a medium thin milkshake or yogurt. Put that on. We want to put on about 1/16 of an inch. This should flow on, and it should be obvious that it's hanging on well. If it rolls a little bit, it's too thick. If it runs too much or runs hardly at all, it's too thin. I practiced on little pieces and then dried them before I got to figure out what the right consistency was. But you can see it looking at that. Okay, again, this is going to be warmed and dry in the warming chamber. It'll take several hours. Put a piece of cardboard down first if you're going to put it on a metal surface, which you should. The next step is going to be to put a refractory cement or a mortar over that. we want to put about 1/8 of an inch of this on there. Be sure this is at least a 3,000 degree mortar. I use a premix mortar, T36 from AP Green. There'll be another video that talks about the source of all these materials and their approximate cost, at least as of January 2013. I mix this up. I had actually went and bought some powdered mortar mix to try, and it seemed like it was as fine as the zirconium, although obviously it wasn't. But any movement of it pushed it into the air, and I had stuff floating. And even with the mask, I was not comfortable using the powder mix. It was just too fine. So I boxed it up and took it to a hazardous waste disposal place that we have here. Put this on everywhere. Remember, the goal is about 1/8 of an inch. If you get a little more than that, it's probably not too bad, but if you get too much, when it dries, it'll crack. This is just air dried initially. We air dry it, and then we file it smooth, or I file it smooth, and then we fire it for the final. Now, let it dry until you see no sign of moisture anywhere. If you have it more than 1/8 of an inch, it's going to take probably more than 24 hours. And you can see that some of mine was a little thicker, and I did get some cracks. This is not catastrophic at all. After it's air dried and I can't see any moisture or smell any moisture or taste any moisture, I use a file, a rough half-round file. We're going to be putting another coat of slurry over this, zirconium silicate slurry, and I want my final product to be reasonably smooth. What we're making here is a high-performance reflective coating, and it does make a difference. When that's done, we have to put the forge back together. Like I said, we have to fire to finish the drying process or the curing process for the mortar. I use a little spacer there because when I put the two coatings on, it took up enough room. It did enough of a build-up so that if I had put this directly down on here, it would have cracked the coatings. Remember, I said I made slots where before I had just holes, so I could slide the forge top down onto them. Again, I have something for support there, just in case I need it. I don't want that bending down. Next step is to install a burner. That burner goes down and stays up in that hole at least 1 inch above the burn chamber. This is important. If you have that too far down into the burn chamber, that flare will burn up almost immediately. Now, some folks have said that you don't need the flare. Well, the burner will probably work in a forge without the flare, but the bottom of that unit is going to burn. You're not going to keep that from happening. It's going to burn. The flare makes for an easier flame to manage, and when it burns and becomes a problem, you can replace it. They last a long time if you keep them up in. Put the doors in. There'll also be another video that talks about shaping fire brick, how to cut it. You can cut it or file it. This is easy. If you have a large masonry saw, like a professional clipper or something like that, you could probably use hard brick in here. I've used soft brick for years, and I consider it a consumable. There's our door. We can open those doors and use long rods in there, or we can come in from the side, or we can take this whole right side out and put larger things in from the side. So start the forge, light the forge, and let it run for at least 30 minutes to fully cure that mortar. And then you'll need to let it set till it cools. And again, that's going to take a few hours for it to cool to be safe. Take it back apart. Our next step is going to be put the last coat of slurry on. Again, we use a 50-50 colloidal silica and water mix to prepare the surface. If we didn't do this, the slurry wouldn't adhere as well. I don't know that this softens anything, but it at least prepares it. And then we use a slurry. Now, the slurry, you have to continually stir it while you're using it. Keep that in mind. The zirconium silicate does not dissolve into the colloidal silica. It's suspended in it, and it's heavier, so it tries to separate. So you just have to keep stirring it. Then we put it in the warming chamber again. We're going to see in a minute that I actually had some moisture where I shouldn't have. Not sure why, but that's how it should look when it comes out of there. This picture shows those little bumps. That means that I did have moisture in there and steam pushed that out. Probably means I didn't, I had problems all along. Those can be repaired. Watch the additional videos. That's it. You can see here that you can see fire on the burn side, on the burn chamber side of the doors, and that's okay. That's okay if there's a little bit of a loss there. The burn chamber has to be able to vent a little bit. Normally it's done through the doors. Thanks for watching.